Okay, today we're going to be doing lesson 10.4, and lesson 10.4 is actually solving radical equations. So we've talked about expressions this whole chapter so far. Now we're talking about equations, so we're actually going to be using some different strategies here to solve. Okay, number 1 says solve and check. So you're always going to check your work when you solve these. You'll find out why you check your work as we go further in. You'll see what can happen sometimes with these radical equations. We're used to checking our work just to make sure we didn't make mistakes. But when we're solving these radical equations, there's times where the solution that you actually come up with, even if you did all the work correctly, doesn't work because of the whole real number solution with negatives under square roots. So you'll see a little more of that as we go through this, but just be aware of it. So we're going to go through a couple examples of example 1. Square root of x subtracting 3 equals 4. You need to be really careful with these square roots because you need to show where it ends. So if this was the square root of x minus 3 and it was all under the square root, that would be different than if what I have here, just the square root of x. So make sure you're really careful with those. Okay, you need to think about last chapter, whenever we needed to get rid of an x squared, we took the square root. Well, now we've got opposites here. Instead of getting rid of x squared and taking square root, we're going to try to get rid of a square root, and so you're going to square it. So just remember that square root and squared are opposite operations. Also remember what I was just talking about. Real numbers, you're not going to have a square root. So a square root can't have a negative under it. I should say under, when simplified. And the reason I'm saying when simplified is because sometimes we'll have something like the square root of negative 3 times negative 2. Well, negative times a negative ends up being positive. So don't automatically jump to this. You have to wait and make sure that that's working out that way. Okay, and then I already explained this, that sometimes the solutions don't work. And because of that, you're always going to evaluate the answer to see. Okay, you're always going to evaluate your answers. Okay, nice thing about this is, again, you already really know how to do this because you've been doing it all year. To solve, you need to just isolate the radical, the radicand. So isolate your square root. It's almost like a variable again. Then we just said in order to go ahead and get rid of a square root, you're going to square it. So if I'm going to square one side, I have to square the other side. So square both sides. Don't forget parentheses when needed. Whenever you have a binomial on one side, you need parentheses around it. And then once you've done that, you solve for the variable. And you're done. Well, check it. Okay, if you're still writing, hit pause. If you're not, then go ahead and move on. So right here, what I need to think about is that I'm trying to isolate my radical. This negative 3 is on the same side, so I'm going to go ahead and add 3 to both sides. Cancels on the left. Now I have the square root of x equals 4 plus 3 is 7. So now, in order to get rid of a square root, I'm going to square. So I take this and I square that, and I take this and I square that. Square root of x squared is square root of x times square root of x, which is square root of x squared, which is x. So remember, we get every 2, we can drop 1 down. So I have the square root of x times the square root of x becomes just an x. Equals 7 times 7, which is 49. And then here's my answer. Now, I need to just check it and make sure it's going to work. So I check it by plugging it in and evaluating. Square root of 49, subtracting 3 equals 4. Square root of 49 is 7. 7 minus 3 is 4. And 4 does equal 4. So that's true. Okay, let's look at another one. This is example B. We have the square root of x subtracting 3 equals 4. Very similar to example 1a, if you notice, but I wanted to show you the difference here. Square root of x versus square root of x minus 3. So here, my square root is already isolated. I can't move that 3 because it's under the square root, the negative 3. So I have nothing else with it. I'm just going to square both sides. If I'd had another number on the outside, I would have moved it over. But I don't. So I just take this and I square it, and I take that and I square it. Remember, every 2, 1 drops down. So I just have an x minus 3. I'm not going to do the big multiplying it out and all that, because I'd end up right back here in the end. Equals 4 squared is 16. And now I solve for x by adding 3. And I get x equals 19. So this is my answer. And then I'm going to go ahead and check that answer. Square root of 19 minus 3 equals 4, which is the square root of 16 equals 4. Square root of 16 is 4, so 4 equals 4. Okay, let's go on to example 2. Example 2 is looking at a word problem that has to do with using this. So in the book, it's talking about a roller coaster. And they actually give you the formula of the roller coaster that they're looking for. The formula is velocity equals 8 times the square root h subtracting 2r. And so if you were to read through this whole word problem, they end up telling you that this is talking about the loop in a roller coaster. This r is your radius, height, and then velocity. and they end up giving you the velocity, and they end up telling you that the velocity is equal to 30, and they end up telling you that the radius is equal to 18. And they ask you for height. So you're just going to plug these in, evaluate, and then solve for h. So I end up with 30 equals 8 times the square root, h subtracting 2 times 18. Okay, you need to isolate the square root. And what's with that square root? You should have noticed there was an 8. 8's multiplying to the square root. So you're going to do the opposite, which is divide. So I'm going to divide by 8 here, divide by 8 here. Now at this point, I'm just going to go ahead and grab a calculator. And when I divide 30 by 8, I get 3.75. This 8 became a 1, and now I have the square root of h, and then 18 times 2 is 36, so subtracting 36. Now I'm ready to solve. I need to get rid of square root. I learned that the way I get rid of square root is by squaring. So I put parentheses and square, parentheses and square. And the reason I'm putting parentheses is I want to follow all those rules. If this had been negative, I want to square the negative. If I had a binomial here, I'd want to multiply it like a binomial, not like we did in chapter 7 with our other exponents with monomials. When I multiply 3.75 times 3.75, I get 14.0625. And then remember, just h subtracting 36 comes down once because the square root squared cancel. Now I'm going to solve for h by adding 36. Cancels on the right. I end up with 50.0625 equals h. So my final answer would be 50.0625 feet high. Okay. So let's just write a few notes about that. You need to make sure there is nothing else on the same side or on the side with the radical before you square both sides. And an example of that seems to cause trouble every year that I kind of wanted to show is like a negative square root x plus 3. You would need to think about that as a negative 1. So what would you need to do? You would divide both sides, or every term, because there might be more terms on the other side. And this is considered a term together, so this side would be divided. But anything that's in, outside of square roots, you'd need to divide every single thing by that negative. Would divide every term by negative 1 to move it. Okay. Example 3, same rules are going to apply again, it just looks a little different. I have the square root of 3n subtracting 2 equals the square root of n plus 6. So what do you notice that's different about this example? You should have noticed you have square roots only. No terms that aren't a square root. So when this happens, it's actually a little bit easier because you just want to get rid of square roots altogether. You're not trying to isolate one or the other. They're all square roots, so I'm just going to square both. Square this side, and then I've got something pretty easy to deal with here. So, when you have only square roots, on both sides of the equation, and when you have only square roots on both sides like that, you're just going to square both sides. And then the square roots cancel. And then you solve for the variable. So those are actually really easy. So I have square root of 3n minus 2 equals square root of n plus 6. And I realize that there's all square roots, so I take this whole piece, square it, this whole piece, square it. The square root cancels. And I just bring down 1, 3n minus 2 is equal to 1n plus 6. One of these and one of these. And now I'm going to solve for n by subtracting an n. Be careful here, don't start making silly mistakes. Remember, it's 3n minus 1n, which is 2n. Subtracting 2 equals 6. And then you add 2. And you have 2n equals 8. And then if we were to divide 2n by 2, we would have n equals 4. Now, I need to actually go check that. I'm out of room on my notes. So let's just look at it mentally. 3 times 4 is 12. 12 minus 2 is 10. So I need this side to also be the square root of 10. 4 plus 6 is 10, and that was under square root, so the square root of 10 is equal to the square root of 10. And that's true. So that solution did work. Okay, example 4. Solve x equals the square root of x plus 6. So, does anyone notice what's different about this one? Square root was, or the radical was already isolated, but you have an x on the outside also. So that's okay, we can still solve these, but what you're about to see is something that you'll remember from a couple chapters ago and from last chapter. So I'm still going to square both sides. Squared this side, squared this side. What I end up with is x squared equals, and then 1x plus 6 group comes down here. Squared and square root canceled, and I get an x plus 6. Now hopefully some of you noticed trinomial here. X squared, x, and then a number with no x. A, B, C. once you see that, you know you can put it in standard form. And once you have standard form, if we're solving, this is solving a trinomial. This is last chapter, solving a quadratic. So you can factor, or if it wasn't factorable, use the quadratic formula. So right here, I have 3 terms, and I have a quadratic. So factor, or use quadratic formula. Remember, if it's factorable, you can factor. If it's not factorable, you have to go to that. So I'm going to move 6 over and move x over, and end up with x squared minus x minus 6 equals 0. Okay, I'm going to set up my diamond, which you should be pretty good at these now. Negative 6 times x squared is a negative 6x squared. The negative x comes down. So all I did was multiply those first and last terms, bring the middle down. What multiplies to be a negative 6 and adds to be a negative 1? I know I have one positive and one negative to get a negative up there. And you probably came up with negative 3x and a positive 2x. Okay, these are the terms that are going to replace the middle. So I set up my rectangle. Hopefully some of you have found the shortcut when there's no a now. I have x squared plus 2x minus 3x minus 6. Those 4 terms. Pull out common factors. Common factor here is 2. Common factor here is x. Here, x, and here, negative 3. Now remember, zero product property, we need to actually go solve these. We need to set them equal to 0 and solve them. So now I have x minus 3 times x plus 2 equals 0. So now I'm going to solve. I have x minus 3 equals 0, so x equals, I add 3 and I get 3. I have x plus 2 equals 0, I subtract 2 and I get negative 2. So these are my 2 possible solutions. Now remember earlier, I said you always check because some don't work. Well, this is the case where a lot of times these aren't going to work. You started with only x's, and by squaring it, you ended up with an x squared. If you think about the rules with x squared, negative numbers squared become positives. So one of these solutions in here is not going to work, possibly. So whenever you have a variable on the outside that ends up getting squared and that changes, that's when you know most likely you're going to find something with one of your solutions. So now you check both. This is one where you really know you need to check both. So let's start with x equals 3. So I go to my original problem, which was 3 equals square root of x plus 6, which is 3 plus 6. So I plugged in 3 for x. And I get 3 equals the square root of 9, and 3 does equal 3, so that one was right. So I can go circle x equals 3 as one of my solutions for sure. Okay, now I'm going to check negative 2. X equals negative 2. Negative 2 equals the square root of negative 2 plus 6. Put those in for x. I should already see a problem here because there's no negative in the front. I'm not going to be able to pull out a negative root here. So I'm going to just show you negative 2 equals square root of 4. Negative 2 equals 2. No. Negative 2 does not equal 2. So x equals negative 2 is an extraneous solution, which means it doesn't work. Okay, it's a solution we got when we solved, and we didn't do anything wrong. It's just by squaring it, this -2 isn't true. So you need to learn the word extraneous solution, and that it means it's something that's not going to work once you plug it back in, even though it was correct when you did the math to solve it. So this was an example of extraneous solutions. And remember, extraneous solutions was when x becomes x squared, one solution might not work. Always check solutions to make sure they are true. Okay, you're always going to check your solutions to make sure that they're true. Okay, we have one more example. So if you need to copy more, hit pause and finish copying. All right, this is example 5. Solve square root of 2x plus 6 equals 4. So a pretty basic one. So you go to solve and you subtract 6 here. And you get square root of 2x equals a -2. So does anyone see a problem with that? Yep, you're right. It's not going to work. When you get that, something like that, where you have a square root alone over here, nothing else with it that could possibly change that sign, then it's never going to equal so what's going to happen? You would just say no real number solutions. Okay, nothing in there is going to work. And if you wanted to, you could continue this, because someone might have noticed and said, well, wait a minute. But if I multiply, if I square both sides, this becomes a +4. That's true, and you could actually solve it, and you'll get an answer. You'll get an answer of 2. But then once you go plug it back in and check it, it's not going to work. It doesn't work out. Because in here, you can't have that negative. So you'd end up with an answer of 2, and when you plug 2 in, you get something that doesn't work. You get the square root of 4. Square root of 4 is 2, and 2 plus 6 is not going to be a -2. So if you wanted to keep going, you could, but when you go plug it back in and check it, it's not going to work. So there's no real number solutions as soon as you see that. Now, you need to watch for this, though, because this is where you could accidentally make a mistake. If I had a -2 square root x equals a -8. Some of you might see that negative and immediately say, oh, no real number solutions. But you need to remember it needs to be fully isolated. I would divide by a -2. Now I have the square root of x equals +4. And then don't get confused about these. They're as easy as they actually look. All you would do, same thing, square both sides. I'd pull out x here and 16 there. And when I plug in 16, Square root of 16 is 4. 4 times the negative 2 is a negative 8. So that one is true. So don't automatically assume it's no solution when you see a negative. It needs to be fully alone, including if this had just been a negative sign alone. That's when you would have divided by a negative 1 on each side. So, over here, if you have just a square root alone equals a negative something, then you know no solutions. No real number solutions for this year. That's Algebra 2. But watch out for negative square root x equals a negative number. Because this becomes divide by negative 1, and you end up with square root of x equals a positive number. So you just have to be really careful with that. And that's the end of this lesson. So tomorrow we'll be working on work for it, and you can ask any questions you have then.